We are taught that human vision is a game of bouncing particles. The standard model says color occurs when incoming photons strike an object, and that object reflects specific wavelengths back into our eyes. This chart captures the classic demonstration. A prism breaks incoming white light into the visible spectrum. Standard optics relies on this sequence. Light already exists, it hits a material, and it redirects through reflection and absorption. This model assumes light must already be present to be altered. It leaves no room for phenomena where matter generates new electromagnetic radiation without a single incoming photon to trigger it. Reflection and refraction explain why a red apple looks red under a sunbeam, but they offer no explanation for how raw, non-light energy inputs convert into visible color. You can see this precise conversion happening in nature. Specific chemical reactions produce excited molecular states that release visible photons. There is no ambient light bouncing off fireflies. The biological system is generating the light itself. Even ordinary adhesive tape demonstrates this. Peeling a strip of tape in a vacuum creates enough mechanical charge separation to generate X-ray radiation. Acoustic waves produce a similar effect. When they strike a microscopic bubble in a liquid, it rapidly compresses and detonates, creating a visible flash. Standard physics places each of these events into isolated silos. The glowing bug is chemistry. The tape is fracture mechanics. The exploding bubble is fluid dynamics. Yet the outcome is identical. Chemical mixing, physical tearing, and acoustic pressure all terminate in the same event, an electromagnetic emission. This recurring pattern suggests a missing structural invariant. Radiative closure acts as a bridge between these isolated mechanisms, connecting the scattered pieces under a single principle. The core equation maps a direct relationship. An external disturbance interacts with a material's internal architecture to produce a specific spectral output. Matter under stress uses its internal geometric structure to find a closure pathway, reconfiguring internal relations to release tension as radiation. The photon represents the event signature of a physical system resolving a constraint. It is a structural readout of how the material is organized. Under this new framework, the photon acts as the universal release valve for structural tension across all of matter. Nature already demonstrates that a material's internal architecture dictates its optical response, independent of its chemistry. This morphobutterfly possesses no blue pigment. Its color is a purely structural readout. The nanoscale geometry of its wings physically shapes the flow of light, resolving the incoming energy into a specific blue wavelength. Theoretical models show that altering a material's quantum geometry, the spacing and angles of its wave functions, can completely change its optical properties. Even with identical chemical bonds, shifting this relational architecture can transform an opaque material into one that lets light pass perfectly through. Color and transparency are relational permissions, determined by how matter is structurally organized. If architecture dictates output, then any structural shift will register in a material spectrum before the object physically fails. Consider an industrial structure like a concrete bridge support. As load increases, the internal geometry warps, fundamentally reorganizing the material's available closure pathways. We can track these shifts in infrared or ultraviolet output to identify the exact location of the stress. This provides a way to predict failure months before a visible microcrack ever appears. The electromagnetic spectrum becomes a real-time, predictive diagnostic readout of structural health. This predictive logic extends directly to human biology. In living tissue, architecture is governed by phase states, the way water and proteins organize into structured gels. A shift from a healthy, structured state to a disorganized, fluid state reconfigures the tissue's internal energy pathways. These structural changes broadcast across the infrared spectrum long before they manifest as a chemical marker in a blood test. Transitioning from viewing light as a fragmented particle to a structural resolution provides a direct window into the body's internal organization. Color and light are the visible edge of a broader spectral language, continuously broadcasting the structural reality of the world around us.